Yeah, so from the last video we have learned how to detect edges by using Ken. So in this video I will show you how to detect contour, or we can say maybe probably border, or yeah, contour. So what is this? These are curves joining all the continuous points having the same color or intensity. So when we want to detect some borders or contours, so we can use just a simple function as always in OpenCV. From now we will learn just a simple function. As you can see, we just use one line and everything is okay. So let's start. Import CV2 as CV, and I can import NumPy. You can see that sometimes I import NumPy but I didn't use it because from my experience sometimes I do not import NumPy and I don't use it and I have some problems, some issues in the program. It doesn't want to load, it doesn't want to run. So I always import NumPy when I'm working with OpenCV. So this is just my trick, but if you do not want to import it, if it is your choice, guys, but you do not have to. But this is just my habit, so I import it. So let's add the image again. We can use CV imread. I will use the same one and I'll load it as a grayscale image, as you remember. So I can, yeah, but to detect contours or borders, I would have to use the thresholding. If you remember last time when we create the thresholding, we get the foreground from the background. So by using the thresholding, we convert the image to binary and we can find really the lines that we really need. So first thing that I do, I convert, I use thresholding. So as you remember, I don't want to know by myself what is the best threshold value to the specific image. So I will use threshold, Otsu thresholding. So it will do it automatically for me. So sorry for the mistake, the image, and from 0 to, so if you know the number of the colors, the minimum and the maximum, CV, and pass the flag trash binary first, and then add CV trash Otsu. Yeah, so I have now the threshold value of the image, so I can add it to my image. So that image or contours, I can calculate them with the evaluation. Yeah, so CV2, the function is find contours. So here I can find it and add it. So I can add the threshold value that I calculated before and CV dot I will use the 3-1, yeah, and CV dot chain approximate. Yeah, so there's there's so many tags that you can use. You can read about it. I go through so many books to know what I have to do right now. So if you want the theory, you can read books or search on the internet what is the difference between those tags and what's the best way to do it. But I don't want to bother you with those theory. So if you want to know the differences between them, so I suggest to look for them and grab the information that you need. Yeah. So let me convert the image again, because we need the bigger the real value. Let's add it better. Color image, CV2, CVT color, and the image CV dot color. Yeah. So remember that the first image that we load, it's on the grayscale because we add the 0 flag here. So we can convert it back to RGB or to BGR. So in this example, I will take it to BGR because I have to do some processes with it and OpenCV. And remember that OpenCV use BGR value to the image. So I can use the image again. I use the same value because I need to pass the image after. And this is a kind of copy of the first image that we get before. Draw contours. Yeah. So by detecting contours, we have possibility also to use the function draw contour, because we can detect them and we do nothing with them. So the user or you cannot see the effect. But when you draw it, you can see it then. It's normal, simple. So we add the color image and we add contours. And you know, when we draw, we add -1 because we don't have to fill it, and the color. So I can put this color from here, and 20, and the thickness 1. Yeah. So I can print out the number of contours detected, number of detected contours. Yeah, I can concat it and string the length of the contours. Sample. Yeah, but if you want the line that we print here, you could try it yourself. Put it on the image also. Yeah, you can pause the video, try it, and then I will do it. Because when you try it yourself, you practice, and this is the best way to know things, to be better on it. Image show. You can give image with detected contours, and add the color image. Remember, it's like a copy. CV2 weight key. Oh yeah, CV2 destroy all windows. Yeah, let me show you. We have canny here, so we have contours here, so I have to run this again. Yeah, you can see I have to again convert or resize the image. You see, I put the same name in, it's never mind. CV2, the resize the image, and I love this number, I don't know why. So let's see, yeah, image with detected contours. We have 331 contours, and you can see by the line, if I add another color, probably remember green, red, blue, or red, green, blue, 0, 0, let's see. Yeah, still the same, red, green. Yeah, we can see it better. See, here we have contours. Yeah, and we have the number. So pause the video and write the text on the image. Yeah, so I think that you're done. So let's do it together also. CV2, put text, color image, and we can just look, copy this line, put it here, and now we need the position like 10, and so I can add like 300, and let me add the font again, the font, or you can just add cv.font, and yeah, before to the font size, the color, can add something like that. Yeah, and thickness 1. So let's see. Yeah, number of detected. Let me add this bigger so we can see the image better. And font, let me see this one. Yeah, number of detected contours 4, 4, 2, and you can see it here also. So the bigger the image, it contains more contours, or because my image is not a purple one, so we could add a better image with better background. You can see here we have a small contours here and here also, but we could add an image with no background, and it will detect better image. But I hope you understand whatever I teach here or whatever I show you here. So this is not the fact that you will have a perfect tools or a perfect picture. So I add this picture and you can see the program or the algorithm find the contours that are in the image. So that's all. See you in the next video.